In section 7.4, we will look at passing arguments to functions by reference. There are two ways to pass arguments to functions. One we are already familiar with, that is pass by value. The other one that we're going to look at now is called pass by reference. So far, all the arguments we've seen being passed in C to functions as arguments were passed by value, with the exception of arrays, of course. Now, many a times you will have a function that needs the ability to change the value of variables in the calling function, the caller function, the function that is calling it. Now, so far the only way that a function can send anything back to the caller function is by sending a return value. Sometimes that is enough, sometimes it's not. Sometimes we would like the called function to make changes to a variable in the caller function. When you have a situation like that, you need to pass access to those variables in the caller function by reference. Another good reason to pass arguments by reference is when you want to avoid the overhead of creating copies of objects or variables in the local function, because that is what happens whenever you pass arguments by value. The way to pass arguments by reference is to use pointers, and that's what we're going to look at now. Now, whenever we want to pass arguments by reference to give the called function the ability to modify the values of the arguments in the caller function, we do it by sending the address of those arguments. Now, this is usually accomplished by adding the address operator, the ampersand, to the name of the variable in the caller function when we're calling a function. And this modification sends the address instead a copy of the argument or of the argument as kind of a local variable. Just one more note on arrays at this point. The same rule can be applied to arrays. Now, we have been passing arrays to functions by simply sending the name of the array, and that's perfectly fine. Please continue to do that. But if you want to comply with what is being said right here, and I think we demonstrated that in a previous example as well, what you can also do is you can stick with that. You can send the array name, the first element, so 0, and you can put an ampersand in front of that. This is equivalent to sending whatever the name of the array is, which is what we've been doing. Inside the called function, you can access the argument using the value of the argument by using the indirection operator. And it can even modify the values of those arguments in the caller function. So let's look at two examples, two versions of a program that kind of accomplishes the same thing. So in the first example, we'll have a main function. In it, we call another function called cube by value. Cube by value takes an integer as an argument, finds the cube of it. So if you give it as argument an integer n, it returns to you n cube. And obviously this will require the passing of an argument, n in this case. And we're going to pass that argument by value first. This is really, should be familiar territory. There's nothing new here so far. The name of the function that will actually perform the mathematical operation of computing the cube, the name of that function in this example is cube by value. Since we're not passing the argument by reference, this means a value the result has to be returned using the return statement, and so it'll also return an integer. And here's the code for that. So we have the function prototype up here for cube by value, the function. It returns an integer and takes an integer as argument. In the main function, we define an integer number and initialize it to 5. And before we do anything, we just print out the value of number. And then we call the cube by value function, pass it number, the number variable by value, and the value that is returned is used to update the value of number in the main function. And then we print out the new value of number, again using a second printf statement. Inside the cube by value function is also pretty straightforward. All we do is we receive an integer as argument. We multiply n by n by n and make that the return value of the function, and that's all. The n that exists in here is a local variable and is really only initialized to the value of number that is received from here. The return value goes back to main and is assigned to number, which we then print out. If you run this program as it is with number set equal to 5 in the main function, this is what the output will look like. So the original value of number will be 5. You call cube by value function, and after that, the value of number will be 125. Now let's look at a variation of this program that uses pass by reference. And in this one, the variable number will be passed by reference. The function that we're using is renamed appropriately. Renamed here, we're renaming it to cube by reference. Cube by reference, because it is taking the value of number by reference, will now not take simply an integer as argument, but an integer pointer, a pointer to an integer, and will rename that appropriately to n pointer, nptr. Now the cube by reference function will also compute the cube of what gets in the argument, but it will, instead of returning a value, it will make the change directly to the variable number in main function. So it makes changes directly to number in main. That is the key difference. And I'll show you everything that happens in this variation of the program step by step in a graphical format that should further clarify it. So here's the modified code. So the function prototype is now for cube by reference. It takes as argument an integer pointer called n pointer. Now since cube by reference does not return anything, it makes whatever it does inside it, the changes it makes to the argument received will affect the value of number in main function directly. So there will be no need to return anything, which means the return type of this function is void. Inside the main function, start is a little similar. We define integer number, initialize it to 5. print out its value using a printf statement. We call the cube by reference function, and here we see another difference. So, like I said, when you want to pass an argument by reference, you prepend, you add an ampersand sign before, in front of the variable, the argument you're passing. Now, because cube by reference will operate on number, will update the value of number in the main function. From inside it, there's no need to return anything. So there's no assignment happening over here like we saw in the cube by value example just a few minutes ago. And finally, we'll have another printf statement that prints out the updated value of number. Now let's take a look at the inside of this function, cube by reference. And you see in here, the argument is an integer pointer, n pointer, and what we're doing is we are multiplying n pointer with itself 3 times. So just to clarify that, these two asterisks are multiplication signs, while these other 3 asterisks are pointer, are the indirection operator. Okay? And the result of n pointer times n pointer times n pointer is assigned to n pointer again. So the value of n pointer is being updated right inside here, right inside the cube by reference function. And because n pointer is a pointer after all, these changes are not just happening to a local variable inside this function. They are happening to the variable number whose address was passed as argument in the cube by reference function. Now, if you think about this for a minute, if you ever have a need for a function that should send back not just one return value, but multiple return values, you could now do that by passing multiple arguments by reference to that function. If you run this one, the output will still look kind of the same. Value of number before is 5, value of number after you call the function cube by reference is 125. And now let me show you a graphical look at what's happening. So key differences over here, of course, the cube by reference function has a different looking prototype because the argument we're passing is, well, an address. So please note that in the prototype, we write this as integer pointer, end pointer. But when you call the cube by reference function, the argument looks a little different. It's the name of the argument of the variable in this case that we're sending with an address in front of it, with an address operator in front of it. So what the prototype of cube by reference is specifying is that cube by reference is to receive an address of an integer variable. All right. One other comment with regard to pointers and arrays. Functions that take as arguments one-dimensional arrays do not differentiate between receiving a pointer or receiving a one-dimensional array. They're being treated as the same thing. So compilers do not differentiate between functions that receive a pointer or a one-dimensional array. Of course, the function itself must know somehow, you the programmer in this case must know, um, whether the argument it is receiving is an array or a single variable. But from the compiler's point of view, when you have this as an argument or whether you have this as an argument, they're both the same. You could even exchange one for the other. Finally, when you pass an argument by value, you are preventing the caller function the caller function is preventing the called function from making changes to the variable, to modify the value of the argument variable. And if it is unnecessary to grant a called function the right, the privilege of making changes to an argument variable, then you shouldn't pass that argument by reference. You should pass it by value. This is also called the principle of least privilege. Basically, you should give functions only as much freedom to change or as many rights to access data elements as are needed. If a called function should not make changes to an argument variable, you shouldn't pass it by reference unless you have some other good reason. But it should be avoided. Here's a graphical view of this last example that we saw, in which we, actually both examples. So let's begin with the first one, where we use the cube by value function. So here we're passing the argument by value. So we begin in the main function, initializing number to 5. So the number variable in main is 5. At that time, the cube by value function hasn't been called yet. So the value of n, the local variable n, in cube by value is undefined. When we call the cube by value function, that's this next step. When we do call the cube by value function, the value of number is passed to the cube by value function and is received in its local variable n, and that value in our example happens to be 5. Cube by value executes its one statement, the return statement. It's one line of code, computes 5 times 5 times 5, which is 125. So it computes 125 and sends that value back to the main function. So cube by value over here is called to cube by value, returns the number 125, which is assigned to number. By that point, of course, the cube by value function has finished execution. So the value of n will be undefined again because it was just a local variable with local function scope. And this is how we end up with number receiving the value 125. And that's the end of the program. As for the other example, cube by reference, in this one, we also initialize number to 5. So number's value is set to 5. We then call the function cube by reference, and the argument, as you remember, is the location, the address of variable number in main. So that location is received as argument, Using the indirection operator, we can access the value of number inside the cube by reference function. So when cube by reference is called, the n pointer now points to variable number in main. So we have communication happening between variables of two different functions. Cube by reference executes its one line of code, evaluates the value 125, which it assigns to using the indirection operator to n pointer. So the value of number in main is updated to 125.